Hello everyone. So this tutorial we'll see how to draw the compaction curve, which is also called as a moisture curve, and sometimes it is also called as a moisture versus dry density curve. So basically this is the curve which you see in the green color. So this one will draw it and will also determine optimum moisture content and the maximum dry density. The example that we are going to use is available over here, and this is the part one of the video. In part two, we'll see how to draw the zero air void curve. So this line, what you see, this is in magenta color line. This one we'll see in part two. Okay, so in the part one, we'll only draw the compaction curve, we'll determine the OMC, and we'll also determine the gamma D max. So if you don't want to watch the entire video, you can just go to the description below and I have given the link for this solution. You can go and check over there. Anyways, so this is the numerical results of the lab Proctor test are shown below. So this is from a Proctor test. This same method can also be applied for the modified Proctor test, whether it is a light compaction or heavy compaction, doesn't matter. So the first row that you see is number of tests. So basically 6 number of tests were performed and the weight of the mold plus soil are given in kgs. So these weights are given to us. Next thing given is water content. So these three things are given. So if you look at this curve, on x-axis we have water content WC. It is in percentage. So this value is given. The only thing that we need to determine are the dry densities on the y-axis. So once we have the dry densities, this curve can be easily drawn. So there is the additional data given. The mold is 12.7 centimeter high, so the height of mold is given. Also diameter of mold is given. So this height and diameter will be used to determine the volume of the mold. Then the weight of the empty mold is given 1.89 kgs. So this weight, if we subtract this 1.89 from this row number 2, you can easily see we can get the weight of the soil only. So this is how we can determine the weight of the soil. Then we divide this weight by a volume, we get a bulk density, and then we'll convert that bulk density into dye density. So this is what we are going to do. Okay, so part 1, we have to draw the moisture content versus dry density curve, which is compaction curve, and we have to determine the optimum moisture content and maximum dry density. So in part 2 of this video, we'll see how to draw this 10% void curve, and we'll also see how to draw the 100% void curve also. Anyways, so the value of G can be taken as 2.68. So this is the given data I have written over here. Next, so as I told you already, x-axis will be water content, y-axis will be dry density. Water content is already given. Let's try to determine dry density. So dry density will be determined using this formula. Gamma D equals to gamma bulk divided by 1 plus W. We'll see that later on. So first thing let's start with determining weight of the soil. As I told you already, weight of the soil we are determining in grams. It is given in kg, but kg will give us the values of dry density in 0.00 something. We don't want that. That's why we'll determine the dry density in gram per cc, so we get better values to plot on our curve. So we'll convert. First thing that we'll do, we'll subtract row 2 by 1.89. So this is your row 2, weight of the mold plus soil. We'll subtract 1.89. Why 1.89? So this is weight of the mold. So the only thing which is remaining is soil. So and I'm multiplying this soil by 10 to the power 3 or 1000 to convert it into grams. So this is how we can get the weight of the soil. So the weight of soil is nothing but weight of the mold plus soil minus weight of the mold. And I'm multiplying it by 1000 to convert it into grams. So these are the values that you will get for each of these values. So this value minus 1.89 gets you this value. This value minus 1.89 again gets you this value. So similarly, you can do all of this. So this is how we determine weight of the soil. Once we determine the weight of the soil, we can calculate the bulk density. So bulk density, the formula is weight of the soil divided by volume of the soil. So volume of the soil, how we can get? We can get the volume of mold will be equals to the volume of soil. So in Proctor test, the mold that we use to compact the soil, that volume we have to take. So that volume will be equals to, volume of the mold will be equals to height of the mold multiplied by area of the mold. So area of the mold is pi by 4 into d square. So diameter is 10 centimeter and height is 12.7 centimeter. So you get the volume of the mold, that is volume of the soil, equals to 997.45 centimeter cube. So we got the mold volume of the soil, we also got the weight of the soil. Now we can easily calculate this fourth row, that is bulk density. Sorry, fifth row, bulk density. So it will be equal to row 4, which is this one, weight of the soil, divided by 997.45. This is nothing but the volume. So each of these values, let me remove all of this. So each of these values, 1.636 into 10 to the power 3 divided by 997.45, that is volume of the mold, gives you this density, and this density you are getting in gram per cc. Why gram per cc? Gram per centimeter cube, because this weight of the soil is in gram, which we have converted from the kg to the gram, and we are dividing by the volume, which is in centimeter cube. So this value is 1.64 gram per centimeter cube. If you keep this row 4 in kg, what will happen? You will get the value 0.000164. So it becomes very difficult to plot on the curve. So that's why we have converted this into gram. So similarly, this value 1.82 you are getting by dividing this value by 997.45. So similarly, all the values you can extract from this formula, rho 4 divided by 997.45. So this is how we get the bulk density. Now, once we got the bulk density, there is only one step remaining, that is to calculate the dry density. So dry density is nothing but gamma, which we have just calculated. This gamma is nothing but the bulk densities, these values. These are the values of the gamma, divided by 1 plus W. So W is the water content in fraction, not in percentage, it is in fraction. So 8.33 divided by 100 will give you the water content in fraction. Anyways, that we'll see later on. Let's go ahead. So now we have reached till this point. Let's calculate the dry density. As I told you, dry density is nothing but bulk density gamma divided by 1 plus W. So this is one example. I have done this one. How you can get the first value? So this is 1.64 divided by 1, which is in the formula, plus water content W in fraction. So this is corresponding to this value. This is the water content. So this water content is the W. W I have divided by 100, so it becomes in fraction, that is 0.085. So this is how you get the value of the dry density in first column. Second column, so let's say this one, you want the answer value 1.65. How you can get it? Simply divide this 1.82 by 1 plus water content. So 1 plus water content is 10.40. It is in percentage, convert it into fraction. So your formula will be 1.82 divided by 1 plus 0.0104. So this is how you will get the 1.65. So all these values are calculated using this formula gamma D. So this is how you get all the values in this equation. So you got the dry density. Now what we have to do, okay, we have to plot this curve. So this is your moisture, that is moisture curve looks like, or compaction curve looks like. How it is plotted? It is plotted between water content in percentage. Okay, now don't plot the water content in fraction. Water content in percentage versus dry density. So water content is taken on x-axis, dry densities are taken on y-axis. So unit for the dry density will be kg. Sorry, it should be gram per centimeter cube, not kg. This is wrong. So it should be gram per centimeter cube. So first point is this one. So how do you get this point? This point is coming from these two values. So on x-axis, you will see where is 8.33. So this is 5, this is 10. So this is somewhere 8.33. And corresponding to this 8.33, you will plot this. So this is like plotting a regular curve. So this is how. I don't think anyone will have any difficulty in plotting your regular curve. So I'll assume that you already know how to plot a curve. So I'll just go ahead. I'll try to determine the OMC. So OMC, how you can determine? Wherever you see the maximum dry density. So this point, approximately somewhere over here, is the maximum value of dry density. From this point, you draw a line vertically downward like this. Okay. So you draw a line vertically downward like this, and corresponding to this water content, at this point the water content is 50%. So your OMC corresponding to maximum dry density is 15%, and the maximum dry density is 1.74 gram per cc. So these are all approximate value. It will not be like exactly similar as I have got. You might get, let's say OMC as 14%. That is also right. The 1% difference can be an instrumental error, can be a plotting error. So 15 to 16, 14% of water content will be your OMC, and dry density should come somewhere like, let's say, 1.75, 1.76, 1.74, and 1.73 will also be fine. So this is how you draw the moisture curve. So only difficult thing in this is to draw this curve. So this curve, remember, is drawn between water content and dry density, which is in gram per centimeter cube, not kg. Okay. So that's it in this video. I'll see you guys in another video.